Hey, 8th grade, here is a video on the friction lesson. So in case you have forgotten certain things or were absent for the lecture, here are the notes filled in, and I will talk through some of these points. I'm going to kind of zoom in so we can see them a little bit better here. So friction is a force that opposes motion, and it happens between two surfaces that are in contact, which means that they are touching, right? If those two surfaces are not touching, there can't be friction between them. So the effects on a ball really just means if you've got a rolling ball, it's going to cause it to slow down and eventually stop. That's how friction works. There are two sources of friction. Through the friction lab, we determined that surface area does not have an effect. So the two sources of friction is the force pushing the surfaces together, meaning another way of saying that would be their weight, or the force of contact. The other is the roughness of the surfaces themselves. So these two are totally related and can't be separated from each other, but they are slightly different. So if you have, every surface has, I'm going to move the notes over here, every surface has bumps. Those bumps can be big or those bumps can be little. If you run your hand over a smooth table like those blacktop tables that we have in the lab room, those feel almost perfectly smooth. So on that table, the little bumps would be microscopic, right? But no matter how big or small, every surface has bumps. So if these are the two surfaces right now, they aren't touching. So there's going to be no friction between them. But if I push them together, meaning I increase the force of contact, so I push from this side and I push from this side, that means that those bumps are going to come closer and closer together until they're touching, and then possibly until they're touching very, very closely and very, very hard. So if those surfaces now come in direct contact and are pushed together really hard, right? I'm drawing this line over them again, meaning that those are the two surfaces now almost inseparable from each other because they're pushed together so hard, means that if you try to move one surface this way and another surface that way, those hills and valleys are going to grind against each other. So whether or not they're big hills and valleys, meaning big bumps, or whether they're little bumps, the closer and closer they get together and the harder and harder you push them together, meaning you're increasing the weight or the force of contact, there's going to be more friction. Likewise, if we go from bumps of this size to bumps of this size, right? If we then have another surface that has similarly large bumps, it's going to take a lot of force to move those two surfaces against each other, meaning the friction will have now increased. So when we're looking at these two sources, force of contact is how hard you push the surfaces together. The harder you push them together, the more that those hills and valleys are going to come into contact with each other, the more they're going to rub against each other, and the more friction you have. Here, the bigger you make those hills and valleys, the bigger you make the bumps, the rougher that surface, therefore the more friction will occur. Really what we're saying with these two is that if we increase force of friction, if we increase the weight, if we increase how hard we're pushing those two surfaces together, there's going to be more friction. If we make the surfaces rougher, there will be more friction. So those are the two sources of friction. But down here, we've got types of friction. Okay, so your two types of friction are kinetic and static, meaning moving and not moving friction. Kinetic means friction that is occurring between two moving objects. So as that ball rolls down the street, it is undergoing kinetic friction. It is rolling along, the ground's bumps are rubbing against the ball, and it slows it down to a stop. So kinetic friction slows things down. In contrast, static friction doesn't allow motion to start in the first place. So static friction, if you push, if there's a heavy box on the floor with a lot of friction between it and the carpet, and you give it a little bit of a push and the box doesn't move, the reason that that box isn't moving is because the friction between the floor and the box is greater than the push you are giving it. So if you really need to move that box, what are you going to do to overcome static friction? You're going to apply a larger force, meaning you're going to push harder, right? If that box isn't moving because of friction, it means you need to move or you need to push it harder. Likewise, if that ball stops rolling and you really needed it to continue moving, you would continue to push it. You would continue to push it with more force, right? So you can overcome friction by giving a greater force. This section, the third section, talks about how friction can be harmful or helpful. Sometimes we like friction. We generally call that type of friction traction, right? When we like the friction. So for instance, if you're driving in a car, you want the tires to have friction with the road. If they didn't have friction with the road, you either wouldn't be able to start moving or you wouldn't be able to stop moving. Or if you turned to the right, you actually would just continue to go straight if there was no traction between the tires and the road. So when we're talking about friction being good, being helpful, we call it traction. When we don't like friction, we want to reduce it. We usually do that by adding lubricants. So like if you're thinking about your car, or your parents' car, they add oil every couple months to the car. That's to keep the pieces inside the car moving easily. If they don't move easily and if there's a lot of friction, they're going to rub, they're going to heat up, and your car is going to overheat and potentially catch on fire. So lubricants are very important when you're talking about overcoming friction or reducing friction. Another way of doing things is to switch from sliding to rolling. Right? If I wanted to move that heavy box, and instead of sliding it across the floor, maybe I could put it on a dolly that has wheels, and now those wheels can roll over the bumps of the carpet as if they almost weren't even there. You can also sand down the two surfaces, make them smoother, or you can make the objects weigh less, meaning decrease the force of contact, right? That would be FOC, and this would be SR. If we, for whatever reason, wanted to increase friction, maybe we're trying to increase traction, we're going to make the surfaces rougher or make them heavier. So for instance, in the winter, a lot of people put snow tires on. Those snow tires are knobbier, meaning they have bigger bumps, and a lot of times the wheel that they're around, the metal piece that the rubber is around, is also a heavier metal, which means that it's going to be pushing on the ground more and therefore have more friction, and in this case being helpful, more traction. So that's a quick review of those notes. Really, when we're talking about friction and the friction lab, this is the key part up in here, and understanding why force of contact and surface roughness has an effect, but surface area does not.